when we're calculating trig measurements, it's all in relation to which acute angle that we're using. So depending on the acute angle that you're using, your adjacent side and your opposite side are going to change, but the hypotenuse will not change. The hypotenuse is always the same, and so that's going to remain your constant. So the way I do this, the way that I try to remember this, is sine is the opposite side over the hypotenuse, and the cosine is the adjacent side over the hypotenuse, and the tangent is the opposite over the adjacent. Now, these are just ratios. These are just fractions, okay? So what we're going to do is set up these ratios and learn to solve for unknown sides and unknown angles using these. Now, luckily, our calculator enables us to do this very easily, so it's nice. So the first thing you have to learn how to do is actually talk about be able to do sine depending on which angle you're using. So we have A and B, which are the two acute angles in a right triangle. So if I was using A, this side right here would be my opposite, and this side here right here would be my adjacent. This is always your hypotenuse. So if we're using angle A, opposite is A and adjacent is B. Adjacent is just the side that makes up the angle with the hypotenuse. All right? So adjacent, and also you can remember it as adjacent means on the side. So that's what we're doing. We're looking for the one on the side. So if we're talking about A, the sine of A is opposite A over C. The cosine of A is adjacent over hypotenuse, which would be B over C. And the tangent of A is opposite over adjacent, which is A over B. Okay? Now, when we're looking at our other reference angle, we have to look at it differently now. The hypotenuse, like I said, stays the same. So now, when I'm looking at angle B, the side opposite is B and adjacent is A. So, sine of angle B is B over C. Cosine is A over C. And tangent is B over A. So it all depends on which angles you're using. Now, we use this little mnemonic device called SOHCAHTOA to help us remember what it means. And I very often use this where I just do sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. You're going to see me write that a lot because I'm going to use that as a reference to help me utilize what I'm doing, to help me figure out which trig ratio to use. Okay, now we do all this in our calculator, but our calculator defaults to radian mode. So everyone should have a calculator with them. And when you turn on your calculator, I'm going to give you guys a few minutes to put this in. Okay, when you turn on your calculator and you press the mode button, which is right next to the second button, you'll see right here where it says normal, float. Let me just reset my calculator. Your calculator will always default to it. So you have to always double check your mode. In trig, in geometry only, we're only using degrees. So do you see how radians are highlighted? I need to change that to degrees. So I go over to degree and I press enter. And so my calculator is now in degree mode. Okay? If I don't do this correctly, all of my problems will be completely wrong. Okay? So this is a very important step, and this is not something I can remind you of when you're taking your SOL or anything like that. Okay? Now, way back in the day, we had a book where we'd look up these trig ratios. Luckily, you guys have a calculator, which is nice. Okay? And we're going to use these buttons right here, sine, cosine, and tangent. And then to get the angles, we're going to use second sine, second cosine, and second tangent. Okay? So first we're going to solve for unknown sides. Okay? This is just setting up the ratio and then solving for it using our calculator, but using algebra to solve an equation. But what I'm going to do here is first I'm going to just go over this question first. This is a 5, 12, 13 problem. So this is a, when we're just giving the trigonometric ratios, we're just expressing these as fractions. So if I'm looking at angle A, sine A is opposite over hypotenuse, so that would be 5 over 13. Cosine of A is adjacent over hypotenuse, which is 12 over 13. And this is opposite and adjacent according to angle A. And then tangent is opposite over adjacent. So that is 5 over 12. Now, when I'm using angle C, this now becomes my opposite and this becomes my adjacent. So it's all about the angle that you're using. So sine C is 12 over 13. Cosine C is 5 over 13. And tangent of C is 12 over 5. You'll probably notice that these two things are the same, and these two things are the same, and these two are just reciprocals of each other, okay? Because that's what it has to deal with. So that's just the most basic problem that you guys will have. If we're given at least 2 out of the 3 sides on a right triangle, I can use the Pythagorean theorem to come up with that. Now this is also a 3, 4, 5 triangle, which is a Pythagorean triple, and I'm going to give you guys a list of that because this is 3 times 3 is 9, 3 times 4 is 12, and then 3 times 5 is 15. Okay? The reason why I like to show you those is because on the SAT, all the triangles are either special right triangles or Pythagorean triples. Yes. Yes, 5 over 13. Thank you. So, yes. Okay, so again, what I do is I always highlight the hypotenuse because no matter what, that's not going to change. But if you didn't recognize this Pythagorean triple, you could always just do 9 squared plus 12 squared is equal to c squared. So that's 81 plus 144 is equal to c squared. And that's 225. And c is the square root of 225, which is 15. Okay? So don't think if you don't recognize that as a Pythagorean triple. It's just there's some portions on the SAT that's not calculator, and a lot of that stuff is the tricks that you can use, right? All right. So doing this one more time, I'm going to use W, so I mark my angle. This is opposite and this is adjacent. Remember, adjacent makes up the angle with the hypotenuse. So sine of W is 12 over 15. And in this situation, it's not necessary that you reduce it, although it's totally fine if you do. Okay? It's really not necessary, but it's totally fine if you do. Cosine is adjacent over hypotenuse, which is 9 over 15, and tangent of W is opposite over adjacent, which is 12 over 9. The one thing I will ask you not to do when you're expressing them as ratios, don't give me decimals unless we're dealing with trying to solve for unknown sides. Okay? So, again, what we can do, which you'll probably notice, is that you'll start noticing a pattern as to what happens when you use the other angle. Okay? So, I'm going to let you guys do this last one because those are really... Now, again, this is also a Pythagorean triple, but remember, we can solve for this last one by just doing, let's just say that's side B. So 16 squared plus B squared equals 34 squared. And that's 256. So B squared is equal to, so I would just take away 256, so B squared is equal to 900, so B is equal to 30. So it's 16, 30, 34, and that is, it's an 8, 15, 17 Pythagorean triple. Again, don't get caught up about learning these Pythagorean triples just yet. Okay, so sine is opposite over hypotenuse, so that's 30 over 34. Cosine is adjacent over hypotenuse, which is 16 over 34. And then I've got opposite over adjacent, so that's 30 over 16. Okay? So that's just coming up with those basic trig ratios, and that's pretty much the most simplistic thing that we're going to do. Now, what happens, and there is some practice that relates to this. Okay? Now, what happens when I want to solve for a missing side of a triangle and I don't have all three sides, I only have one side? I can use these trigonometric ratios to help me solve for the unknowns. So what I do is I tell every time, I'm going to tell you to always highlight your hypotenuse in these triangles. Okay, so, and then I say, okay, mark the angle that is given to you. Don't fill in any other angles, just mark the one that's given to you. Obviously, you could do 180 minus 28, figure out this angle, but don't do that. Just do this. Use this angle right here. And according to this angle, what side is this? Is this opposite or adjacent? It's opposite, right. And then what side is this? Hypotenuse. Very good. So what I do is, again, I do this at the top of my page. And remember, you have to set up your ratio exactly like this. Opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. And so here, which trig ratio uses opposite over hypotenuse? Is it sine, cosine, or tangent? Sine. So what I do is say, okay, well, I know that the sine of 28 degrees is equal to the opposite side, which we don't know what that is, divided by the hypotenuse, which we know is 19. Now, if I was solving this equation for x, and there was just a general number right here, what would I do? How would I solve for x? Multiply. So that's exactly what I'm going to do. All right, so just think about it. Don't get stressed about the fact that this is a trig ratio. It's still just a number. So I'm going to say, okay, well, x is equal to 19 times the sine of 28 degrees. So I put this in my calculator. I say 19, and then I press my sine key, and 28, and I just press enter, and that gives me the other side length. Now, what I want you to do is just round to the nearest tenth, right? So this is going to be 8.9. Okay, if you're not getting this, that means that your calculator is not in the correct mode. Okay, so according to this one, so that's all we did. So I know that the approximate length of this side is 8.9. And when I look at this, it kind of makes sense because this angle, the right angle has the longest side opposite this. This should always be the longest side. This is the smaller of these two acute angles, so it's going to be pretty small. Okay, so here I'm going to mark my angle again. And I label my sides accordingly. So if I look right here, this is an opposite side. And I look at the sides where there's a variable or where there's a side length. Okay? So there's a variable here. That's the opposite side. And then there's a number here, which is the adjacent side. And then I go up here. Which one of these trig ratios uses opposite and adjacent? Tangent. So the tangent of 41 degrees is equal to the side opposite, which is x, over the adjacent side, which is 32. And to solve for x, I get 32 times the tangent of 41. So again, I put that in my calculator. So 32 times the tangent of 41 degrees is 27.8. So that's my, you're never, unless it's a Pythagorean triple, you're never going to get a really pretty angle measure. So just always just round to the nearest tenth. So let's do these next two. Once again, I mark my angle. That's the 21 degree angle. And according to this side, this angle, this is the adjacent side, and this is the hypotenuse. It always just makes it easier for me when I label the hypotenuse. All right. So which trig ratio uses adjacent over hypotenuse? That would be cosine. So the cosine of 21 degrees is equal to x divided by 26. All right, and then to solve for x, x is equal to 26 times the cosine of 21. And that gives me 24.3. So x is equal to 24.3. Now I'm going to do numbers 4, 5, 6, and 7 because I really want to, there's a different type of problem coming up. So here, once again, I mark my angle, and according to this, this is my opposite, and this is my adjacent. So the trig ratio that uses opposite and adjacent is tangent. So I set it up again. Tangent of 55 degrees is equal to x over 8. So x is equal to 8 times the tangent of 55 degrees. And it's just that easy. So it's 11.4. Now what happens if our unknown side is at the denominator? Okay, now I'm going to show you, I'm going to work it through algebraically once, and then I'm just going to have you guys try to do me a favor and try to trust me on this one, because you don't have to work through it every time if you know the pattern. Okay, so 33, I have, this is an opposite and this is a hypotenuse. So that is the sine. So I set this up as the sine of 33 degrees is equal to the opposite side, which is 15 over x. Now, when we have a variable at the bottom, we don't like to be dividing by it. So what we do is we multiply both sides by that variable. And then I have x times the sine of 33 is equal to 15. So what do I do to solve for x here? I just divide by sine of 33. So x is equal to 15 divided by the sine of 33. So when you have a variable at the bottom, all you do is take the number and divide it by the trig ratio. So you don't have to work through that every time. So that is 15 divided by the sine of 33 degrees. That gives me 27.5. And then once again, I'm going to keep going ahead. And this is my adjacent and hypotenuse. So that is cosine. So the cosine of 43 degrees is equal to adjacent, which is 36, divided by the hypotenuse. So now basically the x and the cosine of 43 just switch places. So x is equal to 36 divided by the cosine of 43. Sorry. So that gives me 49.2. So I'm going to go ahead and go through these last two, but then we have some more application problems as well, and then you also have practice in your, more practice in your, packet, in your homework packet. But I also want to show you how to do the other thing as well, which is find out the angle. So let's keep going on this. So again, this is opposite and adjacent. That's tangent. So that's one of the things just to make things easier for you is that I always write this at the top of my page. Okay, one, it's easier to remember, and two, it serves as a guide for me. So if I go, okay, I'm looking for opposite and adjacent, that tells me that tangent is probably the thing to go to. So again, I'm just trying to give you some hints to help you do these a little bit easier. So the tangent of 72 degrees is equal to the opposite side over the adjacent side. So when this is on the bottom, these guys just switch places. So x is equal to 25 divided by the tangent of 72. So 25 divided by the tangent of 72 gives me 8.1. And we'll just do this last one right here. So this is adjacent over hypotenuse. That's cosine. So the cosine of 64 degrees is equal to x over 11. X is equal to 11 times the cosine of 64. So x is equal to 4.8, which makes sense because the longest side is 11, right? So these two have to be shorter than that. So I want to make sure you guys use your reasoning for that. So